Logic programming is a discipline that combines logic and computer science, providing a framework for describing algorithms through logical properties and relationships between objects. This programming paradigm is based on the use of logical statements to express the relationships and conditions that must be met to solve a problem. Unlike other approaches, where the steps to solve a problem are explicitly specified, logic programming defines what must be true in logical terms, and the inference engine is responsible for deducing the results from these definitions. In fact, this approach makes logic programming particularly useful for solving problems where the relationships between elements are fundamental, such as in databases, artificial intelligence, and expert systems. Furthermore, one of the best-known languages in this field is Prolog, which is used to implement logic programming systems. The operation of Prolog's inference engine is based on a process of logical deduction, where logical statements are evaluated to find answers to the queries formulated by the user. In this process, concepts such as reevaluation and cutting are crucial for controlling the flow of inference and optimizing system performance. In short, this paradigm is applied in a wide variety of fields, especially in areas that require automated reasoning and complex problem solving, such as artificial intelligence, optimization, and data analysis.